In this video series, you'll learn how to create a simple communications channel to perform signal integrity analyses. In Part 1, you'll learn how to use the circuit schematic editor in the ANSYS Electronics Desktop. You'll see how components model equivalent real-world electronic parts and devices and accurately predict the behavior of a real circuit. To open the circuit schematic editor, go to the project menu and insert a circuit design. The schematic editor appears along with the component libraries window. These libraries are a comprehensive collection of built-in electronic component models. The components contain netlist data, footprint layout, and parameter data that are passed to the circuit and EM solvers for analysis. To display the available components of each type, expand the various folders. For example, here are the bipolar junction transistors, capacitors, coaxial cables, and diodes. Switching to the Symbol tab, you can also find your desired component from its symbol. Or use the search feature to locate the component. For example, type RES to find a resistor. By using just a few components, you'll build a circuit to test a simple communications channel. In this circuit, the I source models a signal generator. The device under test is a microstrip differential pair transmission line, and the I probe is the receiver. Resistors at the end of the transmission line match the differential impedance of the source and minimize reflections. You'll send some test bits from the source through the channel and create bathtub and contour plots and eye diagrams for signal integrity analyses. An eye diagram is a common measure of signal quality. It is constructed by folding the received bit stream on the unit interval so that the rising and falling edges cross. The width of the eye between crossing times is a measure of signal integrity. The wider, the better. A bathtub plot resembles a cross-section of a bathtub, hence the name. It plots the bit error rates over all possible sampling times in the unit interval. The y-axis is the bit error rate, and the x-axis is the sample time within the unit interval. The width of the bottom shows the range of sampling times that yield the minimum bit error rate. A high-quality channel produces a deep bathtub plot with a wide bottom. A contour plot shows the bit error rates in colors, with the threshold voltages ranging from the lowest to the highest on the y-axis versus the unit interval sampling time on the x-axis. The Verify contour plot is the view looking down into the bathtub. The bit error rate is the lowest at the center of the contour. The contour is widest at the optimal threshold voltage. Return to the schematic editor to construct the circuit. To place a microstrip differential pair, open the distributed folder and click microstrip, coupled lines. Select the first component ms_mcpl_diff. Drag and drop it into the schematic, press the escape key. Zoom in to see the component clearly. From the Independent Sources folder, add a differential I source. Place the I source on the left of the channel. Press Escape. To add the receiver, open the Probes folder and select the differential I probe. Drag and drop it into the schematic. Rotate this component by pressing Ctrl+R 3 times. Place it on the right of the channel. Now place the resistors and ground. From the resistors folder, select RES_resistor and place 2 instances of the component in the schematic. Press the Escape key. Select the ground symbol from the top menu bar and place it in the schematic. Wire up the circuit to complete this simple communications channel. The circuit is now ready to add parameter values for the components before solving. This concludes part 1 of the video series on simple communications channel for signal integrity analyses. In part 2, you will define parameters for this circuit.